In today's video, we will be discussing Physics 251, Week 6 Video Explainer problem number 54. In this problem, we are tasked with finding the shortest distance that a box traveling at an unknown velocity can stop without a smaller box on top slipping off of it. So this is going to be a linear dynamics problem involving friction and just kind of overall force relations. So if you have any questions relating to anything in this video, I suggest going back to the Week 6 lecture notes, specifically pages 24 to 28 and 54 to 63. I believe 54 to 63 covers friction. All right, so let's get into the problem. What I've done is I've written down a few equations and relationships that are going to help us throughout the problem. So I've kind of underlined some givens, and I've actually drawn them all out in this diagram over here. So we have our static force of friction, we have our small m denoting the mass of the small box, and force due to gravity and normal force of the small box. So as opposed to we have the kinetic force of friction, big mass m, and force of gravity and normal force. So all traveling at some arbitrary velocity. So looking at some of these equations here, we're going to be using this equation as our kind of main setup here, but we're also going to take into account this relationship for gravity, as well as Newton's second law, and this relationship here. So this is kind of more conceptual. We need to think about when the distance is the smallest, the acceleration needs to be the greatest, right? Because essentially when the acceleration is the greatest, it's going to be the shortest time that the box will be able to slow down. So, all right, let's go ahead and get into it. So I'm going to start here with this equation. And I'm just going to kind of move it around a little bit. So we have our velocities here, final velocity, and we know that our final velocity, since it's stopping, needs to be 0 right here. And it went ahead and plugged in our d and v naught value that we see up here and right here. All right, so just kind of solving for acceleration here because I want to figure out what the max acceleration is. So kind of plugging in, I get that the maximum acceleration occurs when the distance is the shortest, or d min right here. So next I'm going to go ahead and look at the some free body diagrams for this smaller box on top here. This smaller box is really what we're concerned about, because we're wondering the static friction coefficient when it is at its maximum. We want it to be at its maximum, so of course the ball doesn't go off. It's not over its maximum, but it's still staying on top of the box. So we have our forces in the y direction here. I've drawn a small forced body diagram for that. We get the normal force minus the gravitational force here, which is just going to be 0. In the x direction, we have only the static force of friction acting on the box. So we have it in the negative direction, as you can see here, and that's going to be equal to mass times acceleration, Newton's second law. And then we can just kind of rearrange this here to get this equation. And then when we're solving for the maximum acceleration that we can have, we need to also assume, as I mentioned, that this is the maximum force of static friction here. And when we're at our maximum force of static friction, we have our static friction coefficient times our mass times gravity, all of which is divided by m, as we can see here. When we simplify that out, we're going to set these two equations equal to each other in order to relate both static friction coefficient and the minimum distance here. And after a little simplification, we get that the minimum distance is equal to v naught squared divided by 2 times the coefficient of friction, static friction, times force due to gravity. I hope you guys found this video helpful. Thank you for watching.